Yes. Right. So I welcome you all for today's class. Thank you for your patient waiting for patiently. In my last class, I have discussed two-element array, right? So two-element array, and what is the condition? Equal amplitude, equal phase, right? As I said, to draw the radiation pattern, what we require? We require array factor, right? We require array factor, and we require maximum directions, minimum directions, and half power point directions, right? So four things we require. One is array factor, maximum directions, minimum directions, and half power point directions, right? In the last class, I have derived the array factor, expression for array factor. This one you can see here. So this is the expression for array factor. Maximum directions. So radiation is maximum when array factor is maximum, right? Radiation pattern is maximum when array factor is maximum. So therefore, array factor is equal to 1. That means what? Cos beta d cos pi by 2 is equal to 1. And cos A is equal to 1. Then what is A? A is equal to 0, pi, 2 pi, and so on, right? So that means plus or minus. Even if it is plus or minus, you will get 1, right? Plus or minus 2 pi and so on. So therefore, A is equal to n pi, right? A is equal to n pi, and therefore n is equal to 0, 1, 2, 3, and so on. So A is equal to n pi. A is equal to n pi. What is A? Beta d cos pi by 2. And this is simplifying this expression for pi. Right? Simplifying this expression for pi, you will get this one. Pi max is equal to plus or minus cos inverse plus or minus n lambda by d. Right? So this expression you will get for maximum directions. In a similar way, minimum direction. How you will determine minimum direction? So you will get minimum direction when array factor is 0, right? When array factor is 0, you will get minimum. Therefore, cos beta cos pi by 2 is equal to 0. That means cos A is equal to 0. And what is A? A is 90 degrees or 270 degrees, so on. So that means what? A is equal to, at every odd multiple of pi by 2. At every odd multiple of pi by 2, you will get cos 0. Right? So therefore, 2n plus 1 pi by 2. Right? And where n is equal to 0, 1, 2, and so on. Right? So simplifying this, you will get pi minimum. Pi minimum is equal to plus or minus cos inverse plus or minus 2n plus 1. Excuse me. 2n plus 1 lambda by 2d. Right? So this expression you will get. Right? So therefore, we have expression for array factor and we have expression for maximum directions, and we have expression for minimum directions. And what is the last one we require? Half power point directions, right? So half power point direction. Why half power point directions we require? We require half power point directions to determine half power beam width, right? Half power point directions are required to determine half power beam width, right? So what is half power beam width? I have explained in my last class. Once again, I will explain to you. So this is the radiation pattern, typical radiation pattern, right? So half power means 1 by root 2 means 0.707. It intersects at 2 points, this point and this point, right? So therefore, a line passing through this point, the width between these two, right? The width between these two is half power beam width, right? So this point, let us say A, and this point, let us say B. Therefore, points A and B, right? Points A and B are called half power point directions, right? Are called half power point directions. So therefore, we need to determine these 2 points so that we can find out half power beam width, right? And to determine half power beam width, again array factor, right? Array factor is equal to cos beta d cos pi by 2. So this is array factor, right? Half power point directions occurs when array factor is equal to 1 by root 2, right? Half power beam width, in other words, half power exists when array factor is equal to 1 by root 2, right? Maximum directions occurs when array factor is 1. Minimum directions occurs or exists when AF is equal to 0, and half power exists when AF is equal to root 2. Very simple. So therefore, cos beta d cos pi by 2 is equal to 1 by root 2, right? Is it clear? So therefore, cos something is equal to 1 by root 2. In other words, cos x is equal to 1 by root 2. Then what is x? What is x? So x is 45 degrees, right? X is 45 degrees. So when x is 45 degrees, then cos is 1 by root 2, right? And what is the next value you will get? What is the next value of x? You will get 1 by root 2, 135 degrees, right? Next 1 by root 2 value you will get at 135 degrees. That means what? 3 into 45, right? 3 into 45, you will get cos 1 by root 2. At every odd multiples of pi by 4, you will get 1 by root 2, right? At every odd multiples of pi by 4, you will get 1 by root 2. So therefore, x is equal to 2n plus 1 pi by 4, right? 2n plus 1 pi by 4. right? So therefore beta d cos pi by 2 is equal to plus or minus 2n plus 1 pi by 4, right? So over simplifying this expression, right? So simplifying this expression, what you'll get? So here 2 and 2 times, right? And determine cos pi is equal to plus or minus 2n plus 1 by 2 beta d, right? So further simplifying pi is equal to cos inverse plus or minus 2n plus 1. Here beta is equal to 2 pi by lambda, right? Beta is 2 pi by lambda, right? So therefore if we substitute and simplify, what will get? 2 pi and pi will get cancelled and we have 4d, right? So this you will get, right? And this one is pi half power point directions, right? Half power point directions, right? So this is the final expression, right? So to determine half power point directions, right? So we have everything, right? So we have expression for maximum directions, and we have expression for minimum directions, and we have expression for half power point directions, right? So with this we have completed two element array, and now I will take an example, right? So let me write all these equations at one place so that we could able to refer quickly, right? So maximum n lambda by d, right? Let me write here n lambda by d, right? So pi max is equal to plus or minus cos inverse plus or minus n lambda by d, right? And um, pi minimum is equal to plus or minus plus or minus 2n plus 1 lambda by d. What is the expression? Let me check. 2n plus 1 lambda by 2d, right? 2n plus 1 lambda by 2d. So that expression will get, right? So 2n plus 1 lambda by 2d, right? Let us say this is equation 1 and this is equation 2, and half power point directions is equal to plus or minus cos inverse plus or minus 2n plus 1 lambda by 4d, right? So this is equation 3, right? So now let us take an example, right? Just a minute. Right. So let us take an example. right? Um, Two element array spacing lambda by 2 apart, right? Two element array spacing lambda by 2 apart, equal amplitude and phase, right? So this is the problem, right? So in examination, the problems you'll get like this: draw the radiation pattern. In other words, uh, in two way you will get, right? Sometimes they will ask you to determine the array factor, right? Array factor of two element array spaced lambda by 2 apart with equal amplitude and phase, like that, right? And sometimes they will ask you to draw the radiation pattern. Draw the radiation pattern of two element array spaced lambda by 2 apart with equal excitations, equal amplitude and equal phase, right? That is the problem you will get, right? So therefore spacing is lambda by 2, right? So equal amplitude, equal phase, right? Equal amplitude, equal phase. So therefore to determine, right, to determine or to draw the radiation pattern, we require maximum directions, right? We require pi max, we require pi minima, and we require half power point directions, right? So these three we require. And what is the given data? Spaced lambda by 2 apart. That means d, small d is equal to lambda by 2. That means what? So this is the two element array, right? And this is element 1 and this is element 2, and they are spaced lambda by 2 apart, right? They are spaced lambda by 2 apart. And for this only we have determined those expressions, right? Mathematical expressions for maximum directions, minimum directions, and half power point directions, right? So now let us try to determine the maximum directions, right? Maximum directions, right? So pi max is equal to plus, once again I am writing here, plus or minus what is that expression? Lambda by d n. Am I right? Let me check. N lambda by d, right? N lambda by d, right? So n lambda by d, right? So this is the expression for maximum directions, right? So now what is small d? Small d is equal to lambda by 2 and small n is equal to 0, 1, 2 and so on, right? Let us substitute those values. Pi max is equal to plus or minus cos inverse plus or minus n lambda by 2, right? So what will get? Plus or minus cos inverse, lambda and lambda will get cancelled, plus or minus 2n, right? So this you will get, right? Am I right? Are you following? Now let n is equal to 0, right? Let n is equal to 0. So if n is equal to 0, what will get? Pi max is equal to plus or minus cos inverse 0, right? Plus or minus cos inverse 0. right? So we are keeping n is equal to 0. We are substituting small n is equal to 0, right? So therefore cos inverse 0. Cos inverse 0 in the sense what? 90 degrees, right? 90 degrees plus or minus 90 degrees. So plus or minus 90 degrees in the sense 90 degrees or 270 degrees, right? So these are the maximum directions, right? So these are the maximum directions, right? And one more thing is n is equal to 0 is for major lobe, right? N is equal to 0 is for major lobe, right? Now let n is equal to 1. Let us substitute n is equal to 1. If you expression, right, in this expression if you substitute n is equal to 1, what will get? Pi max is equal to plus or minus cos inverse plus or minus 2, right? Small n is equal to 1. Small n is equal to 1 stands for first side lobe, first side lobe, right? Therefore maximum direction of major lobe, maximum direction of major, n is equal to 0, small n is equal to 0 is maximum direction of major lobe, right? And n is equal to 1, maximum direction of first side lobe, right? N is equal to 0, maximum direction of major lobe, and n is equal to 1 stands for maximum directions of first side lobe. So therefore cos inverse plus or minus 2, what will get? Undefined. So this is undefined, right? So this is undefined. So therefore no side lobes exist. No side lobes exists, right? No side lobes, right? So therefore we have determined the maximum directions, right? And now let us try to determine the minimum directions, right? So just a minute. Minimum directions. Let us try to determine minimum directions, right? So lambda by 2, right? And now minimum directions. Minimum directions, right? Let us try to determine minimum directions. So what is the expression? Pi minimum is equal to plus or minus cos inverse plus or minus 2n plus 1 lambda by 2d, right? Lambda by 2d. Is it right? Let me check. Yes, this one, right? So minimum directions plus or minus cos inverse plus or minus 2n plus 1 lambda by 2d, right? Lambda by 2d. Yes, so this is the expression, right? Right? So now d is equal to lambda by 2, n is equal to 0, 1, 2, and so on, right? So now substitute those, what will get? Plus or minus cos inverse plus or minus 2n plus 1 lambda by 2 into lambda by 2, and this is equal to plus or minus cos inverse plus or minus 2 what will get? 2n plus 1, that's it, right? So because lambda this one will get cancelled, and we have this one, right? So therefore pi minimum is equal to plus or minus cos inverse plus or minus 2n plus 1, right? 2n plus 1, right? Now n, let n is equal to 0, right? Let n is equal to 0. What will get? Pi minimum is equal to plus or minus cos inverse plus or minus 1, right? Because small n is 0, right? Small n is 0. So therefore plus or minus cos inverse plus or minus 1, right? So therefore pi minimum is equal to 0, right? Plus 1, 0, and minus 1, 180 degrees, right? Plus or minus 1, cos inverse 1, 0, cos inverse minus 1, 180 degrees, right? So these are the minimum directions, right? And now let n is equal to 1, right? Let n is equal to 1. What happens? N is equal to 1. Pi minimum is equal to plus or minus cos inverse. So n is equal to 1. If you substitute n is equal to 1, what will get? Plus or minus 3, right? So therefore this is undefined, right? This is undefined. So therefore only one minimum we have, right? One minimum we have, right? And now let us try to determine the half power point directions, right? Half power point directions. So what is the expression? Half power point directions is equal to plus or minus cos inverse plus or minus 2n plus 1 lambda by 4d, right? So this is the expression which we have, right? And now so what is the given data? D is equal to lambda by 2 and n is equal to 0, 1, 2 and so on, right? It's because okay, pi half power point directions is equal to cos inverse plus or minus 2n plus 1 lambda by 4 into lambda by 2, right? So what will get? Plus or minus cos inverse plus or minus 2n plus 1, how much will get? By 2, right? So because lambda will get cancelled, and here 2 is 2 times, so this you will get, right? And now let n is equal to 0, right? Let n is equal to 0. So what will get? Half power point directions is equal to plus or minus yes, anything wrong? 476. You have raised your hand. Let me unmute you. Yeah. Mm, 476. Any clarification you require? You raised your hand. Any clarification you require? Okay. By mistaken, you have raised your hand. Okay. No problem. Thank you. Right. So here half power point directions. So let small n is equal to 0, right? Small n is equal to 0. So cos inverse plus or minus 1 by 2, right? Am I right? This you will get, right? So therefore this is equal to what? Cos inverse 1 by 2. Cos inverse 1 by 2 is 60 degrees, right? Plus or minus 60. And cos inverse minus 1 by 2 is 120 degrees, right? Therefore, half power point directions, right? So these are the half power point directions, right? And now small n is equal to 1. If you substitute small n is equal to 1, what you will get? You will get 1.5 cos inverse plus or minus 1.5, which is undefined, right? Which is undefined, right? So therefore, right? So therefore, we have everything, right? We have maximum directions, we have minimum directions, and we have half power point direction. So therefore, we can draw the radiation pattern, right? We can draw the radiation pattern, right? Now, what are the maximum directions? How much you got? Maximum directions, right? So here, maximum directions plus or minus 90 degrees, right? Maximum directions plus or minus 90 degrees. Minimum directions 0, 180 degrees, right? And half power point directions plus or minus 60 and 120 degrees, right? So now let me try to draw the radiation pattern, right? So now, so let me take the axis, right? 0 degrees, 90 degrees, oh, sorry, 180 degrees, 270 degrees, or minus 90 degrees, right? So therefore, maximum directions, right? So pi max is equal to plus or minus 90 degrees. Pi minima is equal to 0 degrees and 180 degrees, and half power point directions is equal to plus or minus 60 and plus or minus 120 degrees, right? So now let me take another color, right? So maximum radiation, right? Maximum radiation along what? 90 degrees. You have maximum radiation along 90 degrees, right? And minus 90 degrees, right? Maximum, right? Main lobes, main lobe, right? So maximum radiation along plus 90 degrees and minus 90 degrees. Next, minimum directions. Minimum directions in the sense what? Null, right? So therefore 0. That means null in the sense there should not be any radiation along 0 degrees and 180 degrees, right? So therefore this is null, nothing. That means leave it as it is. No need to draw anything here, right? So this is null, right? So this is 0 and this is 0, right? And so this is null, right? So 0 degrees and 180 degrees, right, is null. Next, half power point directions, right? Half power point directions plus 60 degrees. Let us say this is 60 degrees, right? So this one. So this line is 60 degrees, right? And plus or minus in the sense like this, the opposite side. Minus 60 degrees. Right? And Just a minute. Just a minute. Right, and 120 degrees, right, 120 degrees. This is 120 degrees, right, and minus 120 degrees. Like this, minus 120 degrees, right? So we have indicated, right? We have indicated all the directions. Right? So 90 degrees maximum radiation and minus 90 degrees, that is 270 degrees maximum radiation, right? 0 degrees null, 180 degrees null, and 60 degrees line and 120 degrees line are the half power point direction. So these are the half power point directions, right? So therefore this width, right, this width is nothing but half power beam width, right, half power beam width, right? So therefore half power beam width. So what is half power beam width here? This width, that means 120 minus 60 degrees, right? Half power beam width is 60 degrees, right? So this is the radiation pattern of two element array, right? Two element array, spaced lambda by 2 apart. And what is the condition? Equal amplitude and equal phase, right? So this is how we can draw the radiation pattern, right? So with this we have completed two element array, equal amplitude, equal phase, that we have completed, right. Right. So I hope clear till now. If you have any doubts, you can raise your hand, right? So let us stop at this point and let us continue in the next class.